Okay. Yeah, you can see the screen, am I right? Yeah. Okay. Today we will begin to learn chapter 2, the LTI systems. Actually, like I said, today's class is very important because today's class is a fundamental for chapter 2. Yeah, if you don't get today's class, and maybe you will now will now catch the following. Yeah, so before we start today's class, do you know do you remember what is our TI systems? Yeah. Linear and time invariance system, which means this system has both property, linear and the time invariance at the same time. Yeah, we call it LTI systems. Okay, let's review today's goal. Firstly, we will try to compute the general output of a DTCT LTI system by learning convolution. And then we will try to study several convolution-related properties. And lastly, we will try to do a few convolution examples by using the shifting property. Yeah, you will see today's class we will focus on the LIT system and the convolution. Yeah, we will talk about what are those. Yeah, firstly, let's talk about the LTI systems. Yeah, you have already know the LTI system is a linear and a time invariant system. Am I right? So for the LTI system, and for example, this is T, and this is the system. Like the input will result output YT. The input actually will result output. If this system is linear, what does that mean? First, let's try to check TI. If this system is like a time invariant, what does that mean? What does that mean? For the time invariance, time invariance. What does that mean? If this system is time invariance, what does that mean? Which means this system will not change, the system will not change the shape. The system will not change as the time passing. Am I right? It is a good consistency over time t. Am I right? Which means you have this RC circuit. You do the RC circuit lab today and tomorrow and yesterday and 10 days later. Your result will be same. If you use the same resistor and capacitor, that makes sense to you. Yeah, if the system is time invariance, which means it has good consistency over time. Am I right? Yeah. If it's linear, what does that mean? Actually, this is time invariance. If it is linear, which means it has a good predictability from xt to yt, because we have these properties. This one, I'm right? Yeah, we talk about this, I'm right? So which means if you know xyt result y1t and s2t result y2t, and you can combine them together in different form, different linear form, and you can easily to get the output based on the input. Am I right? This is linear like property, which means it has a good predictability from xt to yt. Am I right? Any questions so far? No? Okay. So let's talk about why we want to focus on LTI system. Do you know why? Guess. Yeah, based on like the TI and linear. Yeah, you can see two system properties, linearity and TI, plays a fundamental role in signal and systems analysis for two major reasons. Guess, what's the first one? You can see, we talk about that, the RC circle is a LIT system, am I right? The force system, like the car force system, is a LIT system. What does that mean? Which means like it has a practical value. The many physical processes process the LTI properties and thus can be modeled as a LTI systems. We know like many like physical systems can be modeled as a LTI system. Yeah, that's the reason why we want to focus on LTI system. For example, the RC circle, we talk about the car force system and other many other systems. We can model those systems can be modeled as LTI systems. That's the reason. The reason why. Reason one. And then there is the second reason is theoretical value. We know like the LTI system can be analyzed in great details by their transfer functions, impulse, frequency, responses, and a set of powerful tools, such as convolution, that from the core of signals and systems. This is also very important because the LTI system, we have tons of tools, properties to analyze it. Yeah, if we can like model a system to a LTI system, which means this system is easy for us to analyze. Yeah, that makes sense to you? Yeah, that's the reason why we want to learn. And for the practically, the impulse response and the convolution is very important for the LTI system. Yeah, and in this chapter, the impulse response and the convolution, we will talk about that, and we will learn what are those and how to use that. Yeah, okay. Let's try to talk about what is impulse response and what is convolution. Okay, yeah, those are two different LTI systems. If your input, what is this? What is this? What's the input? Huh? We talk about that. This one, what's this? What's the name for this one? Huh? Five, what? What's the name for this one? Actually, we talk about this one, right? Yeah. What's the name? We like firstly it's a DT, am right? Here is N, am right? So it's a DT signal, am right? Yeah. So we learn. Just remember this function. This function is very important in chapter 2. It's called unit impulse function. DT unit impulse function. Yeah. Do you remember that? Do you remember how what it looks like? Yeah. Yeah. It's just this one. When the n equals 0, it is 1. Otherwise, it will be 0. This is in dt impulse, like unit impulse function. Yeah. And then if a dt unit impulse function goes through a LIT system, dt LIT system, and the output hn, we just define it impulse response. We define it as impulse response, which means this function's name is impulse response. Yeah. Know what is impulse response, am I right? So, do you think the impulse response has a specific form? Yeah. So, do you think it has a specific form for the impulse response? Yeah, we know like the theta n, like a theta or delta. How can you pronounce it? Delta, theta. Usually, how can you pronounce this one? Sorry, this one. This one. This, how can you delta? Am I right? Yeah, delta. Yeah, we know the delta n is specific function. Am I right? Is this one? So hn does hn has a specific form? Inverse? Opposite? Actually, I just want to tell you, actually, the Hn doesn't have the specific form because you can see the theta delta n goes through this system, but this system maybe have many different form. Am I right? For example, your like a like a LIT system is is yn equal like 2x, am I right? Which means your Hn equal what? What? This is the system, am I right? This is your input, this is your output. When your input is your output is what? 2 delta n, am I right? Am I right? But if your like input, but your system is equal what? 3x plus like 4x minus 1 plus 5x minus 2 like plus 2, and then your Hn will change, am I right? So your Hn will equal like 3 delta n plus 4 delta n minus 1 plus 5 delta n plus 2, am I right? Yeah, so which means your Hn actually it will be different, depends on your system. That makes sense to you? Okay, let's talk about this one. Then for any xn, here xn is any like a input signal, am I right? It will equal this one. The output will equal this one. Amazing, am I right? Yeah. Which means, what does that mean? Which means if you have your input and also you have your like Hn, like impulse response, you know your output, am I right? You can represent your output. And we will talk about why the output equal this one. This we call it DT convolution sum. Oh, I forgot to tell you, like this star symbol usually represent convolution. Yeah. Actually, what is convolution? Have you ever heard of convolution before? No? Huh? Equation? Kind of. Actually, I think Matthew, you should because you like many classes in microelectronics. Actually, I talk about this in microelectronics. Like a convolution, it's just like a plus, minus, multiple, divide. It is an operation. You can see it's just an operation, right? Since from here, if your yn equal xn like hn, which means just multiple together or divide together, this convolution is just like a operation. But how this what is exactly convolution is? We will talk about that. And you just know, yeah, you if you have this impulse response and you have your any input signals, you will have your output. Yeah. Okay, let's talk about the CT signal. Yeah, for the CT signal and your input, if it is like what's the name for this one? Actually, we also talk about this one. CT. No. If it is delta, it always impulse. The step is U. Yeah. Yeah, so this is CT impulse, like a unit impulse function. Yeah, just a CT. And then we define HT is the impulse function, impulse response for this system. Yeah, for this CT system. And then for any input signal, you can use this equation to have the output. We call it a CT convolution integral. Yeah. Why this is sum, this is integral. Yeah, because this is continuous. This is just like the discrete, am I right? Yeah, okay. Then this is just like a definition, or this is impulse response, and this is just a convolution. And let's talk about what exactly is. Okay. So yeah, what can we use convolution for LTI system? Okay, actually, well, before we talk about the convolution, let's talk about shifting property. like there is a property called safety property. Let's talk about this property will help us to understand the convolution. Yeah, what is safety property? The key idea is to construct any DT signal as a sequence of individual inputs, weighted and shifted. Yeah, let's talk about it. Do you remember sampling property? Actually, we learned this. Sampling properties is this one. If xn multiple delta n, what is equal? What's the result? Yeah, actually, we talked about this before. Yeah, what is the result? What's that? What is the delta n? Delta n, this is delta n. This one is delta n, right? If this one multiple signal x n, what you can get? Only the value here. Am I right? Yeah, because other value is just 0. Am I right? Yeah, so you can get this one. Am I right? Yeah, we talk about this. So it should equal this one. And we also talk about the after shift, this one. What's the value? What's the result for this one? Do you remember? Huh? What? Go to infinity? Like the form for like do you remember this one? Yeah, because for this one, only when n equal n null or n 0, it should be 1. Otherwise, it will be 0. Am I right? So which means you only get this value. Am I right? So this property we call it a sampling property. Am I right? Yeah. Do you remember? Yeah. Okay. And then let's talk about actually xn. Let's try to find out what's the relationship between xn and sk n minus k. You can see if k here is xn, for example, this is xn, and then this is -2, -1, 0, 1, 2. Am I right? So, and then k should from -2 to 2. Am I right? And delta, then you add this together, and you can get xn. That makes sense to you? Okay. Does it make sense to you? Yeah, because you can see xk multiple n minus k. Only when n equal k, and it will be it will have void value. Otherwise, it will be 0. Right? So from negative infinity to positive infinity, the xn should equal this one. That makes sense to you? This is what we have already talked about. Any questions so far? Any questions so far? Okay. Yeah, and then we call this property safety property, which means the xn equal x like I want to try to extend it to make it clear. Okay. For example, xn, we know xn equals k negative to positive x k and minus k. Okay, let's talk about we can write this equation to k negative k equal -3 x k third and last k -2 k equal 2 x k plus 3 origin x k. We can write this using this equation. That makes sense to you? Yeah, because k from negative infinity to the -3, from -2 to 2, from 3 to positive. Yeah, it's the same thing. It's the same thing. You just like separate it. Am I right? Yeah. For this, what's the value? for this part, what's the value? You can see when k equal negative infinity to the -3, what's the xk? What's the xk value? Yeah, this for them, this is our xn. What's the xk's value? When the k equal like from negative infinity to the -3. Huh? Negative what? Infinity? For example, if k equal negative infinity, what is xk? Yeah, just try to that's xn. So what's xk? Yeah, like the for the xn only here has value, otherwise it will be 0. So what is xk? Yeah, it is 0. So 0 multiple whatever, it will be 0, am I right? So which means if k equal negative infinity, it will be 0. And this value will be this part value will be 0. And when k equal -3, what is xk? Yeah, it is. Yeah, you can see it is 0. So the value is still 0, which means you just add infinity 0 together. What is the result? Yeah, it is 0. That makes sense to you? So which means this part is 0. Am I right? That makes sense to you? So let's try to see this one. If k equals 3, what is that sk? 0? Yeah, because you can see only like a smaller during the is 0, which means this value is 0, am I right? If k equals 4, yeah, 0. If k equals positive infinity, yeah, 0, which means this part is also 0, am I right? Am I right? So then let's try to just remove, because it's 0, we can remove that, am I right? So we just have this one left, which means we just let keep from -2 to keep -2 to 2. So which means this one is just a p from -2 delta plus 2 multiple x -1 plus 1 and x leaves 0 and until x2 delta n negative -2. Actually, you can see this one. What's this one? X -2, which means n only n equal -2, it will be 1, right? So when the n equal -2, this is 1. What is x -2? What is x -2? It's just this value, am I right? If you don't know this value, just this value, am I right? So which means this atom is just this atom, and then the -1 is just this value, and 0 is just this value, and this is just this value, this value. You can see if you represent it, it's exactly the same original signal, am I right? So that's the reason why this equation works. That makes sense to you? Yeah, I just want to try to explain why this equation works. So this property, we call it a safety property. Yeah. Then let's continue to talk about. Okay, let's talk about DT safety property, like example. I think I just talk about that. For example, this one, am I right? And you can see this is xn. We have the other xn, and then for this here is -1, am I right? So here is -2, which means this you can write it this equation you can write it this one, x -2 multiple delta n plus 2, am I right? And then for the -1 you have this one, am I right? And for the 0 you have this one, am I right? And for the 1 you have this one, and for the 2 you have this one. And other thing, it's the same thing. It's a similar equation, am I right? So that's the reason why. Yeah, x for this one, for this equation, other value will be 0. So this equation xn equal what? Will equal x -4 plus sorry. Which means you just try to add this one together. Am I right? This is xn. Am I right? That makes sense to you? Yeah. Any question? Let me ask you a question. Maybe actually here is a tricky thing to understand. You can see, why our xn is a multiple of is add them together. You can see our xn is just like some single value and present in time axis, am I right? So, but here is just a summing form, am I right? If which if it does it mean like I just add all the value together to represent xn? Yeah, I think some students maybe think about this. Why it is just a sum, right? You can see our xn is just a single value in different value, am I right? But you just notice, you can see here xn equal this form, am I right? This equation, am I right? If n, let's try. If n equal -4, what's this value? What's this part? If n equal -4, this, which means here, this is delta n, am I right? So this is just this is 1, am I right? And this is x -2, -4, am I right? But here, when n equal -4, what is this one? Delta -1, am I right? What is delta? What's the value for delta -1?
The value of x at 1.
What?
The value of x at 1.
Yeah, let's try to clarify again. What is the delta n? It's just when n equals 0, it will be 1. Otherwise, it will be 0, right? So what is the delta -1? Huh? 0, which means this one will be removed. Same thing with other item. And then when n equal -4, you just have this item. Same thing. When n equal -3, you only have this item. When n equal -2, you only have this item. Similar thing. That's the amazing part for the like the delta. Why this function is very important? Because you can see we use these properties to get. Yeah, so this is just like the shifting properties. DT shifting properties. Okay, any question so far?
So the reason that works is basically shifting the impulse where it needs to be, and then you plug in and it equals 0.
You mean this shifting?
Yeah, so like that one would be like a shift to the right, but when n is 3, the value inside the 0 after the shift.
Actually here you can see shifting. Now shifting. Here, just pay attention. What is shifting?
I'm thinking about like the equation of how it's the impulse at that thing, like how it gets to 3. Would not put that, I mean, it shifts to the right 3.
Yeah, you can, yeah. Like here, it's just a shift, like a 3 to shift 3 unit to the right, am I right? Yeah, but you can think, just forget the shift, for temporarily. Delta n -3 is just when n equals 3, it is 1. Otherwise, it will be 0. Am I right? Yes, yeah, you are right. It is just a shift. This 1, 2, 3, and 1, 2, 3 here. Am I right? This is just a delta n -3. But try not to connect this one with the previous one because it will make you confused. You just remember like when n when this part equals 0, it will be 1. Otherwise, it will be 0. That makes sense to you? Yeah. Any questions so far? Okay. Okay, this is let's continue. Okay, let's talk about what is exactly why we can. Okay, let's try to like talk about convolution again. You can see this is what we use the shifting property to get that one, am I right? And then from the example, we can get this equation, am I right? And you can see here. Okay, yeah. This one, actually this one. this one. We will talk about later, like the second part. Yeah, you can see this is we consider this is an example, like Xn. And then there is a LTI system. And for this LTI system, we just consider if your input is what's it? Let's try again. What's the name for this function? Huh? Impulse. Yeah. Like a unit impulse function. And let's just define your input is impulse function and your output is Hn. What's the name for this one? Actually, yeah, we just learned that impulse response. Am I right? And then, since this is a LIT system, so which means, yeah, we just name this one impulse response. Since this is a LIT system, and we know this, if we have this input, what is the output? Yeah. Let's guess. Actually, you based on the LIT system property, if our input we have already know if our input is the impulse function and our output is impulse response, and if our input is this one, what's our output? Yeah, since this is the LIT system, what is our output? Yeah, which means if time change, for the output, the time also change. Do you remember that? And if there is a scale, and the output also has a scale. Do you remember? This is the LIT system's property. So the output should like this. That makes sense to you? Yeah, and we just, okay, let's try to talk about the shifting property. Not shifting, shifting property. Okay, you can see this is Xn, am I right? So we can write our Xn as this form. Yeah, we talk about that. And then, yeah, this is our, since we can use shifting property, write down our original signal like this. That makes sense to you? Yeah, add them together like that. Am I right? Yeah. And you can see since this is LIT system, you can like try to depart this system, like separate this system. And after this system goes into this LIT system, what you can get? What you can get? Actually, let me ask you a question. What is x negative 2? A specific value, am I? You can consider it is a constant or specific value. It's similar with A here, am I right? Yeah, I think you're right. It should be like this. That makes sense to you? Yeah, K here is just like a positive 2, like that. Negative 2, and then you just get this one. That makes sense to you? Yeah, and then the next one should this one. Am I right? And then this one should be this one, this one should be this one, this one should be this one. Yeah, based on what we have already defined. Am I right? And this is LIT system. And then this is output. Am I right? And the input plus together is just output plus this LIT system property. We know that. Am I right? So, which means this is YT. YT equals this one. Yeah, this is just a process. We prove what is the YT. The Yn, like the output equals this can represent using this equation. And this equation, actually, we call it a linear convolution sum. Actually, we also use this form, this symbol, like a star symbol to represent it. Okay, just remember. Yeah, this one just equal this one. Like we just simple using this symbol to simple our equation. That makes sense to you? Yeah. So we have already know, like, let's try to ask you a question. Why Yn equal Xn convolution with Hn? Why? Because shifting property. Because this shifting property, the Xn can be represented using this equation. Using this equation, am I right? And then you can separate it. Yeah, because and separated it go through the LIT system, you can add them together after output. Am I right? Yeah, because we know like the a x y y t plus b x 2t equal like now equal just can get a y 1t plus b y 2t. Yeah, actually you can see you deploy it and yeah you can get add them together after output. Yeah, and then you can see we just try to use this thing to prove the yn can be represented like this form. Am I right? Yeah. So yeah, then we have the dt convolution sum, and this is the star symbol is just represent convolution. Okay, let's talk about what is convolution. Actually, convolution is an operation. Am I right? We just use star to represent it. And this is just a definition for the convolution. Convolution, what? Let us ask you a question. What is convolution for now? If you convolution xn and y hn together, convolution xn and hn, what you will do? It's just like multiple them together and add them together. Yeah, this is just convolution, multiple and add. Yeah, so let's talk about, how about this one? And yeah, we know this one equal this one. Now, how about this one? This one equal what? I have give you the definition. Yeah, so just replace this part to this part. Am I right? Am I right? Yeah, so we can get this one. Yeah, why? Because here this is n, here is n minus n now. So here is n minus n now minus k, because here is a k. Am I right? Yeah, so which means for now, we just suppose hn equal this one. Am I right? We just suppose hn equal this one, but hn, remember, hn not always equal this one. It's just like we suppose hn equal this one, and then, yeah, this, which means when n minus n naught minus k equal 0, when this situation, the delta will equal 1. Otherwise, it will equal 0. That makes sense to you? Am I right? Yeah, so which means when k equal n minus n naught, and it will be, this part will be equal 1. Otherwise, it will be equal 0. So which means this, actually, this equation equals this one. Does it make sense to you? Any question? Okay, yeah, this, which means this part, if you see this form, and then you will know it will equal xn minus n naught, which means if hn equal this part, this thing, this equation, and then it is a delay system, because your n grid it will shift to right. Am I right? It is a delay. And then if your n smaller than 0, it will be an advanced system. Does it make sense to you? Yeah. So this, we call it a shifting property. Yeah, I know this is maybe is a little confused. This is a shifting property, but just now we talk about shifting property. So yeah, so this is the dt shifting property, which means if your xn convolution with this form, and this result will equal this one. And for the CT, if your input convolution with this signal, and you have this signal output, that makes sense to you? Yeah, this property, we call it a shifting property. Actually, we will talk about several convolution property, and this property will help you to simplify your calculation, your equation. Yeah, this property, we call it a shifting property. And then let's talk about communication property. Yeah, for an LIT system with impulse response Hn, we have the Ti convolution sum to compute Yn given an output Xn. Yeah, we know like this equation, am I right? We have already proved the Yn equal this one, am I right? And then let's talk about if m equal n minus k, like k, when k equal n minus m. Yeah, which means we just try to here let m equal n minus k, and k will equal n minus m, and then we can this part we can use m, and this part we can use n minus m, right? And this equation will equal this one. That makes sense to you? Yeah, and here should be negative from negative positive infinity to the negative infinity because k is from negative to positive. Am I right? Yeah, this is easy to understand. And then this one can equal this one. Yeah, because from negative positive to negative, from negative to positive, it's just the same thing. Am I right? That makes sense to you? Yeah. So you can see from here to here, do you notice the difference? You can see it's just a proof Xn convolution with Hn equal Hn convolution with Xn. That makes sense to you? So which means if you convolution A and A with B, which means you can like change the order A and B. That makes sense to you? Yeah, this is we call it a commutative property. Okay, let's talk about the distributive property, which means here if you have an input and you convolution with H1 and H1 and H2 plus together, and then this one equals this one. Actually, it's just like it's just equal X convolution with H1T plus XT convolution with H2T. Actually, this part is here, and this part is here. Yeah, it is a cross. Yeah. So yeah, you can see if you convolution with H1 and Xn convolution with H2 and plus together, and your output actually is same with this output. Your Xn convolution with H1n plus H2n, this one. Yeah, we call this distributive property. Yeah, and split or merge the convolution to make a convolution computation easier. Yeah, sometimes you have this one, you can put xt like out and h2, h1 and h2 add together like firstly, and then convolution, which will make your convolution easier. Yeah, any questions so far? Okay, this is distributive property. And let's talk about the associative property. Yeah, which means if your xn convolution with H1, then convolution with H2 will equal, yeah, this one is similar with your xn convolution with H2 and convolution with H1, and equal xn convolution with the H1 and H2 convolution together, and that convolution with the xn. Yeah, actually, it's just similar with multiple. Yeah, but it's just a different operation. Yeah, but this is we call it associative property. You can prove that. Yeah, does it make sense to you? Yeah, which means the order doesn't matter. Yeah, if three different signals convolution with each other, you can convolution A and B firstly and then C, or A and C firstly and then B, or B and C firstly and then A. Yeah, that makes sense to you? Okay, this is associative property. And compute the simple pairwise convolution first when there are more terms. First, sometimes A and B, maybe convolution first, it will make your computation easier. It just depends on. Yeah, okay. Let's talk about one example. Okay, this is our xn, and this is hn. Yeah, so we know yn equal this one, am I right? Also equal hn convolution with xn. And then you can see this is your hn, am I right? Convolution with xn. And let's try to use distributive property. After we apply distributive property, what we can get? This one, am I right? Distributive, am I right? Just try to put, and then You can see what property we can use. Familiar with this one? Familiar with this one? What property we can use? Familiar? Am I right? Shifting property you can use. Yeah, actually you can see if you write the equation here, and then you use some like some this equation to calculate. Yeah, you can do that, but it's not like a very efficient way. So some properties you can use here, and then you use the shifting properties. Am I right? Yeah, here shifting properties, and for the based on the shifting properties, you can easily get this one. Am I right? Yeah. Here, the n now here is just negative one, right? So the x put the negative one to n now, then you can get x n plus one. Am I right? And then we haven't yeah. And then this one is just like here is and n now equal one, and then n minus n one. Am I right? So the coefficient is just like get it here, right? The coefficient will not affect the result. Then what is xn minus one? What is xn minus one? We know xn, am I right? What is xn minus one? Sorry, plus one and xn minus one. You just need put n minus plus one to there, and n minus one there, am I right? So you will get this one. That makes sense to you? Yeah, so then you try to simple. Yeah, you can see some items can combine. Yeah, that makes sense to you, and then you can get this one. Am I right? Because this one and this one can combine together, it will be this one. And this here. And then this just put it here. Am I right? Yeah, so you get the example. And then let's try to talk about the other. I don't think we have time to talk about the other examples. We can continue to talk about next class. But while we learn those properties, it's easier for us to calculate. Yeah, computation. Yeah, but just try to remember why our output is we can represent it in a convolution form. Yeah, that makes sense to you? Okay. This is our today's class, and we have homework. Yeah, this is homework 2. Okay. Yeah, but yeah. For the homework 1, any questions, problems? Okay, any question, problem, just let me know. And if you have questions, you can find me tomorrow, like by email, or we can have a Zoom like a Zoom meeting. I can like talk about that with you. Is that okay? Okay. Good luck for for the Friday.